Good morning, everybody. I hope you're having a great NDC Sydney so far. I quite like speaking early on, not only in the week, but also in the day, because at the moment, you're probably all still fresh, caffeinated, so I'm hoping for a bit of an eager audience. I'm a little bit jet lagged. Although I used to live in Sydney, I lived here for many years. I just lived actually just down in Leichhardt, which, you know, depending on the state of George Street, is either a 30-minute bus ride or a 2-day bus ride away. You know, I mean, I'm not even going to get into this. It's just a mess. Anyway, we're going to move on. So now I moved back to the UK recently, and it's great to come back to NDC Sydney for a second year, and it's great to see that even more people attending this year. So I hope you enjoy the rest of the conference. Hopefully you're here today to learn about my confusion around serverless, which we'll be getting into a moment. Some of you may know I wrote a book about a year or 2 years ago called Building Microservices. This is not a microservice-oriented talk, really. I'm more looking at the serverless technology generically. It has some applications in that space. After working for ThoughtWorks for many years, I then joined a startup called Atomist, and then left Atomist when I moved back to the UK, and I've now started my own business called Newman Associates. It's not the most imaginative title, but there you go. It's my accountant's idea, right? At least it does what it says on the tin. I've been reflecting actually quite a lot at the beginning of the year for a number of different reasons. Because 2017's been a fairly momentous year. Although, you know, I mean, I think it's earth-shattering, the things that have happened this year. I'm not really reflecting on the things that are happening in politics in terms of these earth-shattering, world-changing events. I'm more talking about the fact that I turned 40, and that, I mean, I know you're all shocked because I do look good, but you get into self-reflection, and that's partly, you know, you have to spend a lot of time thinking about yourself, which is quite, it's not something that comes easy to me well, I suppose it does because I'm a narcissist. But, I mean, look, I named the company after myself. I mean, come on, right? But yeah, I was thinking about my age, and I was feeling increasingly old. And I don't really understand some of the stuff that's going on in the world, and the serverless stuff was just confusing me. I mean, I had to remember, you know, I remember when the internet used to come on a floppy disk, actually a 5 1/4, I think was the first time I had it, rather than these 3.5-inch floppy disks. I remember that burst of excitement when I got my first 14.4K modem and the internet was suddenly really fast. And now pictures loaded like this, rather than like this. It was amazing. Oh, is it going to be a cat? Is it going to be a cat? Yes, it's a cat. That's the mystery we used to have. Imagine that. And when everyone's web page just looked like, it just had animated GIFs of workmen doing this, and it just said under construction everywhere. When the Facebook was still called the Facebook, for what it's worth, I still insist on calling it the Facebook. And you know, now of course, no one uses the Facebook anymore, I don't think. I think we're all on what, you know, Snapchat or the My Face space. Like my son's always there with his Snapchatting app, and he's doing this, he's going like that, and he's watching some TV, and he'll turn out funny. He'll make a funny face, and he'll I don't know what's happening, and I'm feeling a bit old. And the thing is, I'm not that much of a fuddy-duddy when it comes to serverless stuff in the grand scheme of things. I was using Amazon Web Services stuff from the very beginning, like from way back in 2008, 2009, when all they had was just the ability to like store binary data, and that was kind of it, and the Mechanical Turk. I had lots of fun with the Mechanical Turk, trying to dream up imaginative ways to spend my money getting strangers to do things on my behalf. Never quite worked out. And so, you know, I feel like I should really be able to get my head around this whole server stuff, but it's been a bit of a slippery concept for me. And so really been speaking to a lot of people doing research, trying to work out what on earth is going on, but I still find myself quite confused as to where on earth I should go or what I should do. And a lot of it does actually come down to that name, serverless. It's like, okay, that name is difficult, but we're going to get into that. Now, of course, as you may be aware, serverless is, of course, riding high. Here's the obligatory reference to the Gartner hype cycle. Here you can see microservices apparently have peaked, which is not good for me, given that I rely on my book sales. So I'm probably have to write a book on serverless now. But yeah, serverless is probably sort of, you know, going to come up and probably peak even higher, because it is, of course, at the moment, as we are all aware, serverless is the golden hammer to hit the silver bullets into, magic and wonder. But of course, I keep coming back to that term serverless, and it rubs me up the wrong way. This is ironic coming from somebody who talks about these things called microservices, because, of course, the first reaction I have is, well, there are computers, right? I mean, so the idea that this is serverless doesn't actually make sense. And what is it even referring to? Probably the first reference to serverless computing was actually way back in 2012. I say way back, like that was years and years ago. But in the grand scheme of things, it was. And it was this post by Ken Fromm. And he just coined this phrase. It may well have been around before, but his was the earliest definition I could find that was well cited. And this was his definition of what serverless meant. The phrase serverless doesn't mean that servers are no longer involved. It simply means that developers no longer have to think that much about them. So computing resources get used as services without having to manage around physical capability or limits. So there's something about an abstraction here. Yes, of course, there are computers there, but you don't really have to engage with them at any level. And it's kind of interesting, though, because this is 2012, and yet when I speak to most people around what serverless is, really, a lot of people actually really start talking about the function as a service. They start talking about things like Lambda, but Lambda came out in 2014, so serverless is obviously much bigger than just functions. But it is, these things are incredibly empowering. The idea that as a developer you have this lovely platform abstraction over these computing resources. You don't have to worry about pesky things like resource limits or scaling. These things are just going to happen for you. And of course, it gets everybody really excited. And you think, oh yeah, this is great. This is a wonderful worldview. And it's fantastic and everything else. And I'm talking to people now who are increasingly looking at trying to build effectively serverless platforms inside the organization. But of course, the reality is, there are still machines there. So from the operations people's point of view, they're like going, what the hell's going on here? You're all talking about this serverless crap. I'm still here. I'm still valued. Now, of course, with Amazon, you're using Amazon's operations people, but increasingly this is going to change. And this sort of gave me another realization that, to an extent, serverless is actually about a point of view. Right? It's, from our point of view of the user, these systems are serverless. I have this nice abstraction. And understanding people's point of view is quite important, It's great from my place. It's all going really well. I mean, from living in Australia or living in the UK, Donald Trump is funny. I think if you're in the US, it might be a bit different. We had that definition in 2012 that was sort of vague, but talks about abstraction, talks about being a bit further removed from the underlying computing resources. And an old colleague of mine, Mike Roberts, did a really nice he tried to break this definition down a bit more. He did a blog post recently on Martin Fowler's site, which some of you may have read. It's a good article. I thoroughly recommend reading. It's actually quite a really detailed breakdown on serverless and some of the pros and cons and puzzles and things. And he actually goes to another level of defining what serverless is. And he comes up with sort of these 5 rules for serverless computing. And I think it's not a bad step. The first thing he sort of says is, OK, well, for it to be serverless, you really need to think about no management of server hosts or server processes. So you're not even thinking about, I want 5 of these things. You don't even do that. You don't say, I want 5 instances of something. You just put an application on it, or you put a function on it, and that's handled for you. These things should scale up automatically and auto-provision based on the load that's coming in. I'm not configuring an auto-scaling group. It's just going to happen magically. This is actually an interest. This idea has been around for a long time. This is quite hard to do because often cloud computing platforms will be tuned for the common case and may not always react as quickly as you need them to. But the sort of serverless functions and features we're seeing at the moment work quite well with this model. Your cost should be based on precise usage. This is why some people get very excited about functions as a service. Right? The function's not running unless there's a request being made. You're only, people are actually making huge savings just by moving some of their processing over to functions, avoiding the need to run a process. It's not actually doing any jobs right now. Performance capabilities are defined in terms other than host size or count. I think you could argue is a duplication of the first point. And that you've got some kind of implicit high availability. So in other words, you don't have to worry about resiliency. That's handled for you. Like magic. So this is this is a better sort of detailed definition to help us understand what a serverless offering might look like. And you think about it, right? This works really well when we think about functions as a service. These things map, right? Cloud functions, Amazon Lambda. These are very simple models, right? You have a trigger that executes a function, a very short-lived function, like so on Lambda, those are capped to 60 seconds. And once the operation completes, the function is no longer running, it's disposed of. These are really, really useful systems. It's kind of interesting, though. I think a lot of people forget where Lambda came from. Really, Lambda, in Amazon at least, was actually kind of created as a way of gluing together Amazon's various different services that didn't really fit together. And so everyone was always writing their code to sort of, well, I've got to take some stuff out of Kinesis and put it in S3. And functions are really just a way of gluing together all these disparate services. Of course, that's why things like the API gateway happened later. But serverless platforms also encompass things like backends as a service. Things like Bigtable, things like DynamoDB, SimpleDB on Amazon, and the equivalents on Azure. Something like RDS doesn't really fit the relational database service. I'm not spinning up an instance. What I'm doing is I'm storing my data, and Dynamo is going to grow accordingly. So these backends as a service. This is kind of interesting, because I was thinking about, I often talk to people about platforms. I work with clients that have built their own platforms internally. And I keep coming back, actually, to what I've always considered to be the gold class developer experience for a platform. And that's been Heroku for many years. It's still the best developer experience for general purpose application hosting in the cloud. It's why Cloud Foundry copies Heroku. It's why things like Dees try and recreate the Heroku experience sitting on top of Kubernetes. But Heroku isn't serverless by Mike's definitions, because you are talking about spinning up Dynamo, spinning up workers. You're still talking in terms of the units of processing. Those processes are running there whether or not they're actually being used. So you have to manage those things yourself. So that, but I've still built really useful things on Heroku. It doesn't mean it's bad, it's just not serverless by Mike's definitions at least. But there are other things that do fit Mike's definitions. Do you know what fits Mike's definition of serverless? Salesforce.com, so specifically Force.com part of Salesforce. This is an automatically scaling platform as a service where you can write code in things like Apex and deploy them. This effectively, Salesforce does all that for you, but we don't think of it as being a serverless platform, and yet it kind of is. Do you know what else would work as a serverless platform? Well, actually, if I'm thinking about something, I want to execute some arbitrary code only when it's being used, pay based on usage. Content delivery networks fit Mike's definition of a serverless, doesn't it? Something like Fastly. I could host a client-side single-page app application out of a CDN. I'm only paying based on how often that thing gets downloaded. That fits Mike's definitions, and I don't really think it fits the spirit of what serverless is about. So I'm not quite sure we've got those definitions right, really. And of course, now we're in a world where we are overloaded with acronyms. Right, we've got our infrastructure as a service, the place where really, I've been happy for a while. I'm thinking about machines and networks, and it's like, right, I've got like 100 machines now, and I'm connecting them. I'm plugging in like EBS volumes and stuff. It's all, it's amazing to think that we now consider that stuff to be low level. Low level used to be crawling around in racks, plugging cables in. Now low level is, infrastructure as a service. We've had the emergence of what some people have called container as a service type stuff. These are things like Amazon's ECS service, Microsoft's awesome new, pay by the second container service. Kubernetes really arguably fits sort of in that space of container as a service, at least when it was initially launched. But of course, then we talk about the higher level platforms as a service. Things where really I'm not focused on a container, I'm focused on my application. And thinking about those levels of abstraction, both functions as a service and backends as a service sort of fit up in that PaaS world. And really, so thinking again, coming back to what I think the spirit of serverless is about, at least from the point of view of the application developer, I think what it really is trying to deliver on the promises of what a platform as a service always was supposed to be. This was always going to be the future. We thought any minute now we would have a good, viable platform as a service experience that gave us what Heroku gives us, but on a more wide variety of platforms out there. I mean, ultimately, this is what things like Kubernetes are now trying to do, what Cloud Foundry is trying to do in the corporate, right? These things are building higher and higher level abstractions. You can now get serverless frameworks that sit on top of these container platforms. And then, of course, I look at a slide like this, and it makes perfect sense to me, but I spend all of my time looking at this stuff. And, but it gets very, very confusing when you're trying to talk, is this IaaS or KAS? Or is this BASSS? And then you start ending up feeling like a little bit of a, anyway, an ass. And it was sort of interesting, so I'm still trying to unpick all this. You're reading, you're trying to get your head around this problem space. And it was actually kind of nice to see Kelsey Hightower come out recently. I mean, Kelsey's one of the big people in the Kubernetes community, come out and say, I now understand what all this serverless fuss is about. When you have a great idea, the last thing you want to do is set up infrastructure. So sort of, I think he was slightly tongue-in-cheek, because I kind of feel like he's worked that out. He's a very smart guy. He would have worked that out earlier than this. But this is the vision of the platform as a service was always what we were promised. You have an idea, you write some code, just go and make it work. That's why Heroku's been so empowering for other people. It's why some organizations are loving having things like Cloud Foundry internally. And the serverless stuff this is what it's about, really, is giving us this experience. And then I come all the way back again to that original definition. The phrase serverless doesn't mean servers are no longer involved. It simply means that developers, which is probably most of the people in this room, no longer have to think that much about them. This is, in a way, the serverless offerings now are just better abstractions over computers than we've had in the past. And that's simple in a way. They are sort of carrying on what Amazon started with their infrastructure as a service offerings. Amazon Web Services started to create tools to allow developers and operations people to avoid what they call this undifferentiated heavy lifting. What they meant by that, you have these teams that want to create services, provision them, run them, maintain them, support them. But they were spending all of their time doing things like racking up kit and provisioning stuff and plugging in networks and things. And so Amazon Web Services grew out from the internal initiative in the company to give people the ability to say, actually, I want to focus on my business problem. I don't have to focus on all this low-level stuff. And what's happening is just through experience, we're creating better and better abstractions for developers. Okay, so I feel like at this point, after my research, I felt a bit better about what I think serverless is. And still very hyped, but okay, right, I've got a sense of what it's about and what it's trying to target. But there are still a whole bunch of things that are unanswered questions and puzzles for me. One of them is actually about resiliency. Now, this might be as a surprise to some people because, of course, Mike's definition was implicit high availability. These are things where you can offload your concerns about resiliency because the platform's going to manage it for you. Amazon is smart, so you don't have to be, right? That kind of thing. So many years ago, I was working at an investment bank in the UK. That investment bank no longer exists. Part of the reason it no longer exists was because of some of the things that the team I was working with were doing. I'm not sure how many of you have seen the film The Big Short or read the book. The book is excellent, by the way. And this details really one of the trigger points from the global financial crisis. And one of the things that was happening as part of that were people were creating these things called collateralized debt obligations. This is when you take a whole load of bad debt, and you bundle it all up together, and then you say, and now it's all good debt. These people that you thought may not be able to pay back their debts, you get all of these mortgages together, and you go, and now it's all good. And they explained this to me when I first joined the team, and I said, explain that to me again. How's that happen? You take loads of bad stuff and you put it all together and then you say it's good, right? And they go, yes. And I say, how? And then they said Black Scholes and waved their arms a bit. And then I said, I'm clearly stupid. So, okay, great. We'll just make sure that we can price these things, these trades, and process as many of these things as we possibly could. Turned out it wasn't stupid. It just doesn't work. Apparently, if you do take loads of shit and bundle it all together, it's still shit. But anyway, it took us a while to work that out, and some people got very rich, and a lot of people got very poor, and the film talks all about that. But nonetheless, I was having a lot of fun at the time, because we were trying to price these things and handle these trades as quickly as possible. The idea being, we want to scale this stuff up. The more volume you can do, the more money we're going to make. And we're actually running this sort of system to handle these trades on what we used to call, it was actually a grid. We were using grid computing. That's what we talked about before there was a cloud. And so we had all our little pricing nodes that would sit there, pulling in data from various different sources. So we had systems that were providing information about risk. We were putting in market data information, so seeing what was happening out there. And then we would do all our calculations and we store some information in the database. Believe it or not, part of the reason we were using this particular product, a product called Data Synapse, was because an awful lot of these calculations historically were being done in Excel spreadsheets on traders' desktops. So there's a really interesting world where a trader would get given a bonus based on how good the trades were that they were making. And the calculations that told you how good the trades were that they were making were running in Excel that was running on their desktop. And so they were doing things like, oh, I'll plug some figures in, the number comes out and it looks like not a good number. Okay, I will just go and tweak the algorithm a bit until the number comes out to be correct. And some people had pointed out that's probably not a good thing to be doing. And so our job was to centralize it. So believe it or not, a lot of what we were doing were running like Excel solutions on a massive compute cluster. One of the nice things that Data Synapse could do was it had this ability to run in screensavers. And our price, the little calculations we were doing a lot of them, but they were individually quite fast. And so we realized that, at lunchtime, we could increase our capacity by running these screensavers throughout the bank, and they then became workers in the grid. And then one of our friends in the operations team said, well, look, we have these whole disaster recovery centers. So all the trading houses in London have other offices ready to go in case there was an incident in London that meant you couldn't do trading. You'd actually go a bit further outside of London, and there's a whole trading floor waiting for you, so you don't lose money, you don't miss out on too much time on that time. And so there's this whole office just about 20 miles north of here. They've got like 300 or 400 computers, and they're all turned on and are active because they have to be to make sure they're working. So we could just run all of these algorithms, all these pricings on this fleet. We'd massively increase how quickly we could go. And we thought, that sounds awesome. So we did that. And then some interesting things happened. So suddenly, our pricing grid, we suddenly drastically increased the number of nodes we were running on. We'd scaled it up hugely. And the way we built our pricing algorithms worked really, really well. And then some really interesting things started happening that were very confusing at the time until we realized what had happened. We had this infinitely scalable thing in the middle that we could now stretch out and it could do loads and stuff, but every single thing that we talked to, that we pulled data from, or that we wrote data to, that wasn't in that grid, got wiped out totally. We blew up so many downstream services that we got a lot of people very cross at us. And this is sort of thing is problematic, right? When you've got this infinitely scalable thing, you have to start thinking about throttling. How do you throttle connections to downstream things? Like we took out the database, we had too many writes going into a database. Now, normally what you do is the way you handle that is that you sort of throttle the number of database connections is using things like connection pools, right? So you think about inside a normal application. If you're going to talk to a database, you have a connection pool that has a fixed number of workers. And so as requests come in, those requests will wait until they can get a worker out of the pool. That limits the number of calls that are going to be going downstream. And this actually becomes a throttling mechanism. So now we can limit how many inbound calls we're going to have and manage the load around those databases. That's part of the reason we use connection pools. It helps us order that load. And so, this acts as a throttling mechanism. The other thing it does is if those things are blocking and they can't get a worker because the database is slow, those threads actually time out. That's actually a load shedding mechanism. And that's really great, so we throw that stuff out. These are useful things, but the problem is that connection pools require state. You are persisting some aspect of state between calls. You have multiple workers. How does that work in a function as a service world? Same problem, right? Same problem we had with our grid. These things weren't around long enough to maintain that state. We had too many of them. In the function as a service world, great, I can infinitely scale up my functions. As more load comes in, this platform will spin up more instances for me. Those more instances are going to make more database requests. Where's my throttling mechanism at this point for anything that isn't itself also a serverless backend? So if I've got a traditional database that I'm talking to, I can very easily just have more load coming in and cause a downstream outage by wiping out that database. Like on Amazon Lambda, for example, you have very limited ability in terms of how you can throttle these things. And the best you can do is throttle the number of invocations of your functions. And it's not a very graceful mechanism for doing that. So this one mechanism that we've been using for years without even thinking about it, that gives us properties around resiliency and allows us to handle failures, we've just lost that without even thinking about it. Now, of course, the answer is, well, that's fine, Sam. The way you solve that is to say, well, we'll just use the backends as a service. We'll just use Bigtable. We'll just use Dynamo. Because those things are elastic as well. And so then those things will balance. And you know what? That kind of works. And that's great. But that kind of implies that you're all in on serverless. And for most of you, I think for you creating a brand new application, maybe you can build it only out of serverless components. But for most of you, you have an existing system, and you probably want to start introducing serverless components into it. So when we start thinking about hybrid applications like that, we have these interesting impediments mismatches that occur. And so I was thinking, I was wondering, like, because given our experiences of that investment bank, where we'd had a similar problem, where we'd effectively scaled something up, we'd had mismatched capacities and blew this thing out. And I was wondering if this was actually was this just a theoretical problem that I had with serverless, or was this a real issue? And then I saw a really good talk by someone from Bustle at NDC Oslo this year. And they're famously kind of all serverless and serving like 60 million unique users a month. They're not all serverless, by the way. Actually, if you talk very openly, they're not all serverless, although they've got a poster child for the use of Amazon's serverless features. They had exactly this problem. When they were migrating over to using Lambda jobs, they just wiped out all of their Redis clusters. And they had to do an awful lot of work in terms of how they tuned their Redis clusters, how they were having to do stuff at the networking level to handle the connections, because anything that wasn't in that serverless platform suffered from these impediments mismatches. It's a real issue for some organizations. So saying you get this amazing out-of-the-box high availability, that's fine for a local concept around your local functions, but it may not actually give you high availability of an overall application stack. There are other areas where we make use of state between calls, local state, to give us resiliency, and that's in things like circuit breakers. You know, if I think about how we normally implement a circuit breaker, it's a very simple idea. You know, I've got some downstream calls. I'm making this example. Maybe I'm talking to my risk service. And if that service, as we've got load coming in, if that downstream service is behaving unhealthily, maybe it's timing out, what you do is you just pop the circuit breaker open and you degrade functionality. You effectively go to failing fast, you reduce the resource contention, and again, you sort of shed that load. You degrade gracefully. It's a very, very common pattern for how you deal with synchronous calls and how you make those more resilient. But again, this requires state between calls. It's not, you can't have a circuit breaker that only exists for one call, because you have to see, okay, I sent 5 calls through, and 5 of those calls have actually errored in the last 10 minutes. That's unhealthy now. You don't have that ability. That's sort of gone. And that's a problem as well. So I'm starting to think, you know, well, what's the answer here? Because we've lost these throttling mechanisms like database connection pools, like circuit breakers that throttle and shed and avoid cascading failures. They don't really fit when we start thinking about the functions of the service world. And I'm starting to think, well, actually, we might need something that fits in between our functions and things that aren't themselves part of the service platforms. I'm not quite sure what they might be. I do wonder if this might be answered by some of the service meshes that are out there now, things like Linkerd and Istio, but those all really rely on running proxies next to the things that are executing. You can't do that with these functions, because this is a platform that's abstracted from you. I've spoken to loads of people about this problem, like people who spend their whole lives working serverless stuff. A couple of friends of mine run a consultancy. It's all they do. They're all serverless all the time. I think they've got that on their T-shirts. And they go, yeah, it's a problem. I'm like, so how do we solve it? And they go, yeah, it's interesting, isn't it? It's like, well, is that the answer? And he goes, yep. Let's move on. So, and maybe this isn't an issue, right? Maybe you're not building systems that are going to be mixed and have these bursting loads and high loads, where you can't necessarily provision enough capacity in the things that aren't serverless to deal with the load, you may not have real legitimate high load, high availability requirements. You might just wish you had. But then I'm thinking, well, if you're not in that world, then a lot of the stuff that serverless gives you doesn't really matter anyway, right? So that gets interesting too. So resiliency is a puzzle to me. Security comes up a lot. There have certainly been some people who have been critical, certainly of Amazon's offering, that there's been some security problems around their implementation of Lambda. I mean, under the hood, the Lambda functions are just running inside containers, right? We know actually early doors, it was just running Docker under the hood. You could poke around and see all the containers and stuff like that. And of course, that starts making people a bit worried, because we know that actually the isolation of container technology isn't as good as the isolation of virtual machines. So there are all kinds of situations when you're just looking at normal Docker containers in which one container can gain access to the host operating system and to other functions. So, you know, we try and avoid this sort of stuff, right? We say, no, if it's untrusted code, if it's other people's code, run it in a VM. When you spin up an EC2 instance or a Google Compute instance, you're running in a virtual machine. There are other people's workloads running on the same physical machine, but the virtualization keeps those things apart, so we have less concerns. But what about containers? That's what's happening here with these functions as a service. Are we worried about that? The reality is it's a bit different, right? Because here's my code and it's executing. And what we're worried about is, OK, could somebody else see my container? Could they gain access to it? Could they sniff the information that's running? The thing is, though, this is much less of an issue than people worry about, because if my function isn't running, my container's not actually there. It's also very hard for somebody to target my functions, because there's no guarantee about where my functions are going to be. So any sort of attack that could happen within that sort of container engine is only going to be opportunistic. And the other thing, of course, is you're not being given a raw container in these situations with functions as a service anyway. What you're actually being given is a sandbox which happens to be executed in a container. You're not actually at that raw container level. And so this actually is much better, right? You can't hack something that isn't there. You're not giving people access to the raw container engines for these functions as a service. From a security point of view, this is actually really good. Kinda, because some of these functions really do vanish when you don't use them, and some of them don't. If you're using JVM-based functions, the JVM has a spin-up time. Right? The JVM is not designed for fast spin-up execution. It's designed for sort of consistent performance, running, handling large scale. The way all the JIT caching works is it takes a couple of minutes often to warm up a JVM effectively. And so the way Amazon gives you some adequate response time for JVM-based functions is they pre-warm some of your functions, and they will leave them around for a bit of time. They won't charge you for it, but they'll leave them lying around so subsequent invocations can reuse that JVM. That means they are floating around longer than you think they are. This was actually, the Bustle team found this out as well. Part of the load issues they were having on Redis was they were hitting the 10K limit on each Redis instance. So it had 10,000 active connections. You can't run that many functions, but those functions were actually being left lying around, and they could see the connections. And that was really interesting to them, because they suddenly realized, well, actually, that means these functions are living for a lot longer than we think they are. So this isn't as clear-cut as it could be. I'm going to be especially interested in looking into the details of Microsoft's container per second sort of priced offering, because that is more like a raw container. Other concerns that get cited are things around lock-in. And this gets talked about a lot in the context of the cloud. And I think there are some legitimate concerns here, because when the cloud was first talked about, everybody became obsessed with this idea of cloud is utility, or it's going to be a glorious world. You can just move from provider to provider. You can go where the market wills it. Google Compute Engine has reduced their price by 1 cent. I will move over and save myself $10 whole. And it will be seamless and wonderful. And it's a lie, isn't it? Because most cloud services we use are not utility in the true sense of the word. You know what's utility? Well, electricity is utility. So the UK has a deregulated energy market. I can go to a site like USwitch and say, Tell me the cheaper deals I can get. I can click a button, and then my provider changes in 2 days. And nobody notices. I just get a bill from a different person. At no stage did I have to rewire my house because the voltage of the electricity was different. So this idea of cloud as utility doesn't quite work. It's not as seamless as that. And so what I've always talked about with lock-in in cloud in general is actually spin it around. Don't think about lock-in, think about the migration cost instead. Like when you take a cloud, any cloud service, what you're always doing is you're trading off the potential lock-in or the potential cost of migration against the fact that I don't have to do the work. I can just use this load balancer. It works, bang, done it. That's a whole lot of time I've saved. I'm trading that off against the fact that I might later on have to move to a different provider, maybe move on-premise, move over to someone else. And so, when you think about some of those services you use are much easier to migrate than others. So I always sort of think about spectrums, the cost of migration, right? If I think about something like blob storage, so Amazon S3 is an example of blob storage, binary large object storage. Moving blob storage is actually quite simple in a way. You can just ask Amazon to send you you can send them a hard drive, they send it back with all your data on it, and you upload it to Google. I mean, the equivalent services are quite similar to each other, so the migration cost isn't too bad. Compute, ultimately, yes, the way you might spin up an instance is the same, but once you've got it, it's a VM, and VM's a VM. They're pretty portable, so the migration, if all I wanted is a different machine over here, that's quite low. Load balancers, likewise, they're pretty easy to recreate, easy to spin up your own. When you start getting into other things, though, it's different. Like, the functions of the service offerings are different. They have different characteristics. These are things that may not be portable as you think. In fact, back-end as a service, I think, are significantly more problematic. You cannot recreate the semantics of Dynamo anywhere else in the world except on Amazon and except on Dynamo. Redshift is the same. Google's Bigtable is the same. At least with Google Bigtable, you can kind of go to Cassandra, which is similar-ish. Your migration costs for those things are much higher, and you've got to decide, is that something you're worried about? It does come back really to this decision you've got to make. It's like, I can pay now, as in I'm going to implement it myself, and therefore come up with a portable solution, but I've got to maintain that, or pay later. And so, you've got to think a little bit about some of this, especially when you're embracing the serverless stuff, which at the moment, at least, from the offerings we've seen from the public cloud vendors, don't really seem to be portable in the way a lot of their other offerings are. Sort of in this space, some people say, well, one way I can handle this is, well, I can mix my vendors up. That way I can hedge my bets. I don't think this makes any sense. It was interesting, one of the early benefits was cited around microservices as, we can be polyglot. We can pick the right language for the right job. We can pick the right database for the right job. And if you're like a 10-person development team, you do not want to be supporting 2 or 3 or 4 or 5 different databases and 5 different programming languages. It's insane. You spend all of your time trying to work out, okay, so how do I do stuff in Clojure? Oh, we've got stuff in Ruby. How do I build stuff in Ruby again? In reality, that stuff doesn't really make much sense. At an organizational level, sure, have a mix of technology. But this whole idea of polyglot, I think, doesn't really work for small scope stuff. And I think the same is for cloud vendors as well. Like, if you want to use a serverless platform, I think you're just going to buy into the fact you're all in on that platform for that use case. But maybe over here for a different product, a different part of your organization, maybe you do try Amazon or Google somewhere else. But you also get a little bit, I don't know, we always sort of think lock-in's bad. That we're stuck in some walled garden. That's the phrase. That's the nicer phrase we use. That's the walled garden. The thing is, sometimes lock-in is perfectly fine if that walled garden is really nice. If you really love being there, it's like, I'm kind of all right with this. I am all in on the Apple ecosystem. You know what? I absolutely appreciate I've locked in. This watch only works with this bloody phone, only with an Apple phone. I can't swap out an Android phone and have my watch work. Do you know what? I don't care. Because as walled gardens go, it's really nice. It's lovely, it's beautifully manicured. People bring you free drinks. You sit by the pool. You hear the babbling brook. I've been locked into some other walled gardens which are not as quite nice. The walls are falling down. There's ivy everywhere. It's full of cockroaches, and you just want to leave. But these actual walled gardens, especially around the server stuff, it's still really pretty good. So I wouldn't obsess about that stuff at all. So where are we? Well, I spent my time trying to get to a sense of what serverless is, and I think I've grasped, and really it's just another name for platform as a service. Ones that are just maybe slightly higher level abstracted, but that's really all we're talking about here. I think there were some legitimate unanswered questions around the resiliency side of things. And I think everyone could do better about security. There are other areas as well where they're still quite problematic, especially the functions as a service. People have been working for the last couple of years trying to work out how on earth do I work out why my function failed, what happened, how can I trace the calls through my system. Amazon in particular have done a really good job with that recently with things like X-Ray. They've now got their SAM stuff, which is nicely named, where you can actually run and execute and debug functions now locally. You can run Azure functions actually now on-prem. This is actually making it much easier for you to diagnose those issues, and so those things are getting fixed in short order. I think we're also going to see more and more frameworks that give us things like function as a service on platforms that we might run ourselves. So there's probably 3 or 4 of them now that will run like, we give you functions as a service on top of Kubernetes, for example. And I'm sure Pivotal would have put something into Cloud Foundry by now, if you part with this big enough check. So there's some stuff in there that's great and that's wonderful, and I'm starting, and I think these things can be really empowering. There are still some puzzles out there, and I still keep coming back, and we constantly devalue these terms as well. Right? We had agile, and agile meant something for a while, and then it's like, it took about 10 years for us to just completely devalue what that term meant. DevOps came along, and that took us about 6 or 7 years to completely dilute the meaning of DevOps, maybe less than that. Come and buy DevOps. Buy my DevOps. I want 15 DevOps, please. Just install them here in the rack, and everything's going to be fine. Microservices, they probably had a good definition for about half an hour, right? It's like Moore's law is applying to how quickly we devalue these terms, and serverless is sort of, it already means a bunch of mush to a bunch of people. There's also this mantra, okay, well, we've got to be all serverless all the time, and it's like, well, really? Just kind of use what works. We do have this fundamental truth, though. As Luke Kane said, he's the founder of Puppet. He said many years ago, there is no future with fewer servers. There is no world in which we aren't going to need more computers doing more things. Guess what? The number of computers that we're producing, the number of computers we require, is drastically growing fast, much, much, much faster than the number of computer software engineers we're creating or the number of people who are going into operations jobs. We need leverage to use these computers well. And serverless platforms as a service, are one of those nice abstraction points that give us the ability to work with and manage these computers without having to deal with some of the detail that was inside them. So I hope I haven't turned you off to them. I do think they're really interesting. I don't think they solve every single issue. As always with any new piece of technology, give it a go, try it out. Maybe not on your most mission-critical stuff to start off with. There are some people out there that have got some great examples of how wonderful and empowering serverless technologies can be, but just do dig into the details behind the hype, especially don't take the case studies that come from the vendors at face value. So thank you very much for your time. I'm here all week. Try the buffet. I'm doing a talk tomorrow on application security, and I think in about 20 minutes I'm going to be doing an Ask Me Anything in room 8. But thank you very much. So we do have time for questions, if there's any questions out there. If nobody wants to ask a question to here we go, question here, third row, fourth row.
I think you raised a really good point, which is how quickly technology is changing. It's not just around server technologies per se. So how do you think companies can continue evolving with all these new trends in the market that are still not in the stability phase and just keep up with it? Isn't it like a vicious cycle? You invest in technology for like 5 years, 10 years, and then you have to invest again?
Yeah, so the question for those that maybe couldn't hear it is there's technologies changing all over the place, not just in serverless, elsewhere. New technologies coming up all the time. How do you handle that? Do you invest in technology that then ends up becoming obsolete? I think the reality is that every organization has sort of a different appetite for adopting edgy technology. There are some organizations that are very, very happy to really invest in picking up some new piece of technology, hoping it's going to give them some massive boon. And they're accepting of the fact that they're going to back the wrong horse occasionally. There's maybe organizations that really are technology organizations to the core, that have people that keep up on the latest trends and are therefore better able to assess that stuff. You have other organizations, of course, which really, they want more stability. And so I think the key thing you've got to understand first is what kind of organization are you? And even within an organization, you might have variation, right? So I've got, okay, this is where we make 90% of our money. Maybe let's not experiment here, because we might screw it up. And so the first thing is you've got to understand your appetite. I think what you've got to do is you've got to create spaces in your organizations where you can actually safely try new things. That's kind of one of the areas why microservice architectures can be useful, because you can try a change locally on one service boundary, for example. But there are other things you can do. There's other non-mission critical applications. Maybe you're a little bit more okay with trying something new there. I dislike it when people come and say, we're a .NET shop or we're a C# shop. And it's like, you shouldn't define yourself in terms of your technology, right? Because that's a guaranteed way for you to be behind the curve. You should define yourself in what you do for your customers. Technology is a means to an end. And so you've just got to create spaces where you try and bring new ideas that come into the organization. And it's just how you vet that stuff. And so other things is I'd always look at case studies, read up, try and contact the people who put those case studies out, ask some questions. Some of those people are really happy to share their experiences. Don't take what I say and as true, right? If I think, get technology and bake it off against each other, try it out. And I think keeping in a wider view of the ecosystem can help. Some areas of our technology space are churning much more quickly than other areas. Kubernetes, there's loads of people that run great production loads in Kubernetes, but it's adding so many features so quickly that, like, if you're going to use it, for example, maybe actually you stick to a subset of the feature set and ignore those other things. So I've given you, of course, the classic consultancy answer. It depends. I am available for consultancy, by the way, if anyone needs any help. I'm happy to say it depends all day long. I've also got a few mean quadrants I can share too. Any other questions? One over there. Yeah, so the question was, if you had access to, say, a containerized solution, you've also got access to, say, a function as a service-based solution, serverless option, what's going to push you to implement one from the other? I mean, the first is that there were some strict operating requirements around the functions as a service straight away, right? You know, they can't run for a long period of time. They've got to execute in less than 60 seconds. And so that already is going to take out a class of services that you're going to want to run. So services that need to be stateless, for example, those are out. If you can't offload the state, maybe you're keeping state in clusters. That's already going to excuse that stuff. There are limited technology stacks available for the function service. Again, that's going to help push that out. I think where I'm at is I'm starting to push more thinking there. Like now I'm thinking, what can I move? I'm now thinking, okay, actually I'm going to start a new piece of functionality and I'm going to put it there. And so that's sort of becoming a default choice for a lot of people around certain pieces of functionality. The key thing is I don't think they necessarily handle a lot of complexity well. One of the anti-patterns I've started to see is certainly with complex domains is people have hundreds of functions that all kind of get wired together and it becomes a bit of an unmanageable mess. So I still think for complex logic, that still seems to fit within a different type of structured code, but that's really fuzzy in my head. And so for me, it's really just down to, I'm actually pushing more stuff there now, but it's within those constraints. It's not a terribly clear answer I've given, I'm aware. I should write that down, try and clear that thought up a bit. Any other questions? Okay, one here. Yes, the question was, what tools are there for developing and developers and debugging was the area you touched on. So there are really interesting, so Lambda's actually, as a good example, is actually way more painful to set up than it should be. It's a simple idea that's more complex set up than you expect. So there's actually quite a few frameworks out there that actually simplify the task of creating a Lambda function and updating the Lambda function. confusingly, one of the popular frameworks for this is called serverless, which gets really hard to Google for. So there are, if you're working in a certain technology stack, it might be worth you seeing if there is already a framework that helps you manage those functions in terms of uploading them and stuff like that. When it comes to stuff like debugging, basic things can help. Just actually using aggregated logging, sticking stuff in CloudWatch logs, for example. If you've got an aggregated logging platform already, there's no reason why you can't be emitting log lines from your JavaScript functions out. The X-ray stuff is helping a bit. That can theoretically show you traces between how the functions are connected. The SAM stuff I haven't yet tried using myself. That was out kind of fairly recently. That actually allows you to run those things locally, because then you can actually effectively put debug points in your JavaScript function because it's running locally on your machine. And that's obviously good if you're trying to recreate issues. This is still not a completely solved space, though. Because of that abstraction, because it is also ephemeral, you can't go back and grab it and grab that state. And even with container technology, if you've had an outage or a problem, one of the first things you do is not blow it away, is you seal it. You take it out of commission, but you leave the container running, or so you can actually go in and inspect that container and work out what the hell's going on. So I use tools like Sysdig for doing that, capturing system traces on live systems to find out what the hell goes on. We sort of don't have that yet with the functions, and there still feels to me like there's gaps. The flip side, of course, is almost by definition, you're putting smaller amounts of code in these functions, and so your surface area for these nasty complex problems to arise should theoretically be shrunk. I also don't think the other providers of functions as a service yet have all the stuff like X-ray and SAM, so you'd probably have to look into what Azure are doing and what Google are doing around those things. I'm not quite as aware of that stuff. Any other questions? All right, I'm going to let you go. Thank you so much for your attention. You've got a bit of time, a bit of a breather. I'm going to be in room 8 for an Ask Me Anything. They're being live streamed, and I think they'll be recorded as well. And I think you can give feedback via the app, or you can vote. Vote on the way out. That'd be very nice. Thank you so much.